Well, hello, everyone, and welcome to the April 2024 edition of the St. Louis Java Users Group. For those who don't know, our first meeting was in May of 1997, and we're still around. Attendance is free. We're informal, so we don't maintain a formal membership list. Our normal meeting date is the second Thursday of each month, except December when there is no meeting. There's just too many things going on over the holidays for us to organize a meeting in December. Yes, I know it's the first Thursday. We had to make some adjustments here to accommodate our steering committee, but next month we'll be back on the second Thursday. For those of us who are in person, you can join us for food and social at 6 p.m. And we aim to start the meeting at 6:30 p.m. So if you want to get in on the pizza and the social, the training room is the place to be. And so this recording is originating from the Object Computing Incorporated training room, and we're at 12,140 Woodcrest Executive Drive, Suite 310, and we are in St. Louis, Missouri. I'd like to introduce the other members of the St. Louis Java Users Group Steering Committee. So from left to right, we have Ted Doyle, Bruce Alspo, that's me in the middle, Robert Levitt, and Wing Chi Gao in the back. And you can reach all of us on the St. Louis Java Users Group Steering Committee if you send an email to that address at the bottom of your screen. That's javasigsc@ociweb.com. And I'd like to welcome aboard the newest member of our steering committee, Zach Klein. The St. Louis Java Users Group would not be possible without the support of our sponsors. So here's their logos. Object Computing Incorporated has been with us since 1997, and they're sponsoring the training room for us right now and pizza for those who are here tonight. So thank you very much for Object Computing for making all of this possible. JFrog has been covering the subscription for the Zoom meeting, and that allows us to have these meetings online. So we appreciate the help that JFrog has been offering them. At the end of this meeting, we will be raffling 2 JetBrains licenses and 2 Manning ebooks of your choice, but you must be present to win, either online or in person. So if you are watching the recording on YouTube, and yes, we'll be uploading this to YouTube, and I will post a YouTube link probably sometime over the weekend on the Meetup website for this event, so that you can watch it again later. But you must be present to win. And so at the end of the meeting, we'll do a raffle here. So stick around if you're here live. Manning also offers us a 40% off any product discount code. So when you check out, you can use that code JUG13. Other announcements, No Fluff Just Stuff starts tomorrow. It may be a little late to be using the JUG discount code, but if you want to keep up with that, you can look at that address at the bottom of your screen. That's nofluffjuststuff.com/St. Louis. And they were very nice in sponsoring a ticket, which we raffled here last month. So this person can attend No Fluff Just Stuff here for free and tell us if they find any good speakers, maybe they'll show up here at the user. DevNexus is coming up here next week, and that's why we're meeting a week early here, because DevNexus is, we are told, the largest Java users group in Atlanta, and they sponsor the DevNexus conference every year. That's April 9th through the 11th, and that's at devnexus.com. So we'll be sending someone there to steal their speakers. We make no bones about it. We're here to steal your speakers. We do have a sister Java users group, and that's the Kansas City Java Users Group. They put on a conference as well, and it's coming up here June 26th through June 28th in Kansas City. And that's the Kansas City Developer Conference at kcdc.info if you want information about that. As far as upcoming presentations go, next month we have Full Stack from the Back, Java-driven approach to building web applications by Lawrence Lockhart of so he'll be driving all the way into St. Louis to be able to give this one. And I'm trying to see if I can get a spring presentation here for June. I'm still working out the details on it. But if you want to keep up with the presentations as they are scheduled, that's easy to do. Just go to our meetup page. That's meetup.com/gatewaychug. And as we schedule presentations, we'll post them on Meetup, and you can go ahead and RSVP. In fact, you can RSVP for next month's meeting right now. The RSVP is open. If you're interested in giving a presentation or becoming a Chug sponsor, and yes, we need Chug sponsors. We need more than just what we've got here, particularly for things like food. And if you're a recruiter, come on down, okay? Because we've got people here who are looking for positions. Send us an email to that address that I gave you before. That's javasigsc@ociweb.com. We'd love to have you. So those are pretty much my announcements. So I'm going to turn things over here to Josh Spiegel of Oracle, who's going to tell us how to unleash the power of Java, JSON, and databases. So I'm going to stop talking here, and Josh is going to share his screen, and I'll let you take it away.
Okay. Thanks, Bruce. Yeah, so thank you so much for having me. It really is an honor to be here and be able to speak to you guys. I actually used to come to these meetings a long time ago. I think they were over in the same place. At some point I fell out of that habit, but I'm happy to be back. So a little bit about me. I've lived in St. Louis my whole life. I worked for Oracle. I started at DEA Systems, working remotely, and then DEA got bought by Oracle, and then I've been at Oracle ever since. And my current role at Oracle is that I'm a software architect in the Oracle database engineering group. And specifically, lately, the past 5 years or so, I've been working on projects that are all related to processing JSON data. So for example, I'm actively involved in a project right now that allows connecting MongoDB applications directly to the database. I played a lead role in designing and implementing JDBC extensions for processing JSON, Oracle's JDBC driver. And so I'm mostly a Java developer, but lately I've also been trying my hand at C coding and working on some extensions in Oracle's query processor for making JSON easier to process from C. Before all the JSON stuff, started out working on XML projects for processing XML and Apache Hadoop. And we also have a Java query processor for processing XPath and XQuery that's used out throughout middleware services. So that's kind of my story. I started out doing XML and now I'm doing JSON. So my talk today is going to be pretty technical. I don't think there's a whole lot of fluff in the slides, but I wanted to give like kind of a brief warning here. Is that I'm going to start out talking a little bit more generally about like why you might want to model the data, store your data as JSON rather than little rows and columns. And then after that, I'm going to talk about how JSON processing in a relational database works. So for the first 10 minutes or so, I might not say Java a whole lot. And it's, I don't want you to be sitting there thinking that I tricked you or something. But after about 10 minutes or so, it'll all be Java stuff. So a document store. So a document store is a type of database. It's a type of NoSQL database. And one big notable example in this category is MongoDB. So these databases essentially store JSON objects or something like some kind of similar data structure to the JSON. And JSON's fairly simple. It has a small set of types: strings, numbers, booleans, objects, and arrays. And these types can nest within each other as kind of key characteristics. So you can have an object, another object, an array, and so on. And another kind of key aspect of it is it's self-contained. So these values can kind of float from system to system, and they can be read by a program without having to consult some data dictionary or schema repository. And so the example on the slide is an example of a JSON object representing a movie. It has an attribute movie ID, title, the date. And so my group at Oracle is not building one of these documents for us. So our general strategy is that we're building a single database that can handle a bunch of different types of data and a bunch of different workload types over that data. So this is like notably different than say Amazon Web Services, right? So their strategy is to go to their database pages, right tool for the right job. And so they've got a bunch of databases. And that messaging can sound good. But our strategy is that doing that, having a bunch of different types of databases, can be systems that are expensive, complex, and so you have multiple skill sets to maintain, multiple database licenses, ETL processes, things like that. So we're betting that having one database that can do a bunch of different things is going to be good. So the other thing about these special purpose databases is that they can tend to come and go. And so they can seem like a very big deal at the time, but then later on, they become marginalized. The anecdote I like to tell is when I started at Oracle, everybody was concerned about a database called MarkLogic. So I was doing XML, MarkLogic is an XML database. Everyone was talking about how we can compete with MarkLogic. But then like 10 years later, you don't really hear about them anymore. And the other example I have from my personal experience is Hadoop. We worked on a bunch of projects related to processing data in Hadoop. And it seems like, at least from my experience, the kind of activity in Hadoop-related projects is kind of diminishing. But at the time, 5 years ago or more, it seemed like it was going to take over the world. So some of these databases will stay forever, some of them won't, and it's kind of hard at the time to tell which is which. On the other hand, there's a group of databases that are relational and become multi-model, like Oracle, MySQL, SQL Server, Postgres. These databases are popular now, they've been popular for a long time. So this is data from a site called DBN. We're not affiliated with them, but they take like data from LinkedIn, Stack Overflow, Google search engine data, stuff like that, and they kind of mix it all together and come up with like a number that ranks how popular the database is. And so I think something like this you have to take with a grain of salt, like who knows like how this actually works. But 7 out of the 10 of these top 10 popular databases, according to this metric, are relational multi-model databases. But there's one kind of notable thing here, is that in the 5th place is MongoDB, one of these document stores. And I think like 3 or 4 years ago, like they weren't even in the top 10. So they were growing in popularity, which is also what I see in my experience at work. So there's something about this, right? They're the only database in the top 10 that's not, the top 5 that's not on this relational model. But there's something there, right? There's something people like about storing their data that way. So what is that? So one of the reasons is that data stored as a JSON object is schema flexible. There's kind of 2 aspects to this, right? There's schema flexibility up front, right? If you're just writing a Java app and you want to persist your application object, you can do that without having to like create a table definition and figure out what your columns are. But, so it's easier to get started. A lot of people would say that's a form of technical debt. I think they're right, but it's, for some things it's probably fine. The other thing is it's schema flexible over time. So if you want to store a new piece of information, you want to add a new attribute to your web app, you can do that without having to modify a table definition or talk to a DBA. It's kind of seamless in the developer's hand. The other reason we think people like it is that there's less impedance mismatch with your application. So with a relational database with JPA or something like that, you have to map your application objects to these flat relational rows and join them together. With JSON, since it supports these nesting structures, it allows you to store and query your data in a way that's more similar to how it is in your application. And then finally, there's the whole NoSQL part of it, right? It's that SQL's great. It's great for analytics. It's great for reporting. But if you're just building a simple app where you want to, get and put your objects, do some filtering, it may not add a whole lot of value. And yeah.
Can you compare and contrast a little bit? I mean, are you seeing the inroads from YAML versus JSON, or are people just kind of firmly saying that?
So the question is, if you couldn't hear it, are you seeing inroads with YAML? So YAML does come up from time to time. I'm not sure we support YAML database. And while the syntax is very different for YAML, the kind of information set of it is like very similar to JSON, right? So once after you parse it, kind of data structures are kind of the same. For example, I think you see Jackson, the most popular parser for Java and everything, supports YAML and JSON with the same APIs essentially. So yeah, it comes up, but not nearly as much so far. It hasn't kind of.
Is it growing or kind of stagnant?
I can't say. I don't know that I'm a good person to judge. But I do hear about it. But yeah, so the thing with SQL is like a lot of especially younger developers, it can be a barrier to entry, right? To actually embed these SQL strings of your code. So yeah, so MongoDB, for example, calls it data as code. And the idea is that through direct access or through a framework or something, that you're just writing more code, they go into the store and that's what you make, not having to embed SQL. Oh, and by the way, feel free if you want to do other questions. Okay, so that's like kind of all the data modeling and access stuff in these databases. The other thing that kind of people tend to associate with these NoSQL document stores is that they're elastic, right? So as your application demand grows,
this is just simply something I've observed. You have a very large database, you're not going to be able to fit them all in single minute. That's one thing I've seen. So, but I understand this would be great for relatively small databases.
well, no, I mean, so even Oracle or these document stores, they can have a relatively small memory, and to store a lot of data, right? They're persistent stores. They have like, durable writes. Right? So we have customers storing, terabytes, petabytes of data. That's JSON.
In JSON.
Yeah, so I mean that's MongoDB, right? The word Mongo that's for storing big and I think the document stores as well as Oracle database is they're all capable of storing very large distances. So but the idea with it being elastic is not only can you scale the storage, is that you can scale the compute capacity. So as you get more and more requests, you can increase the compute of your database without having to shut it down. The other thing is that these databases in this category are used for what's called operational applications a lot of the time, building interactive applications where response time is very important. And so we've heard several of them advertise that they can support single-digit latency at scale. And so what they mean by that is that for small reads and writes, even when a lot of people are accessing the database at once, they can keep the response time of those operations under 10 milliseconds. And then these databases are also perceived as being highly available and lower cost than maybe an enterprise database. So what we're doing, what our group is tasked with is to bring all these benefits, these features of document stores to the Oracle database. And so today I'm going to show you how you can write low latency, high throughput applications in Java, and without kind of losing the traditional benefits of these relational databases like Oracle, consistent reads, and the ability to access SQL directly over the JSON. Okay, so SQL JSON. So we've been working with the SQL standards group, ISO SQL, for over a decade now to add the ability to process JSON from inside of SQL. And so the first thing we did is added a JSON column type. And the idea is very simple. You create a table, you can add a column of type JSON, and then you can insert JSON data into that column. So the example on the slide creates a table called movies, has a column named data, its data type is JSON, then we insert that JSON into the table. That's it. Now, we've worked in defining the ability to actually query data inside of that JSON column as well. And so the basic idea here is that if you're familiar with relational databases, anything you can do with a row, you can also do that with an object or a nested object stored in one of these JSON. So you can do things like convert JSON to relational, relation to JSON, joins, aggregation, projections, basically anything you want to express in SQL or with this JSON inside that, you can. So the example on my slide here, and for that movies table, here it's doing SQL group by query, where it's grouping by the genre attribute inside that JSON column. And it's projecting out a new JSON object where it has that genre, action or sci-fi or something like that, and the total gross sales within that category. We also have a way to take data stored in nested arrays in JSON and load them out into rows in SQL result. This is one of the features that I got to work on inside the database. So we added a nested clause here. So nested allows you to identify arrays and make it so that the objects in those arrays become repeating rows in the SQL result. So here it's taking an array of actors and it's projecting out 8 actors. So we've been working on this for over 10 years now, but there's been some really interesting changes in this area the past few years. So when we started out, the JSON that we would store was stored as text in the column. And a lot of databases did it the same way. But more recently, we've started storing the data as a binary encoded format we call OSON. And we're not alone here. So all those databases that I showed you on that slide earlier, Postgres, MySQL, they all have binary formats. And the latest one was just a few months ago, SQLite. You've heard of that now. Even they have a binary JSON format. So we have this binary format, and the last few slides I have here before I get into the Java stuff kind of explain what the point of having this binary encoding is. The reason I'm going to go into this detail is because it impacts how we interact with the data from Java. So the first reason that we wanted this binary format is so that we can add more types. Okay, so regular JSON just has this small set of types: object, array, string, numbers. But we added some more types. We added floating point numbers, timestamps, intervals, and logs. And we wanted these extra types here for 2 reasons. The first is that if we have a row in this table here, and this row might have like a timestamp column, if we converted that to a JSON object, a regular one, we have to convert that timestamp into a string. Whereas now we have a timestamp type, so we can go from the row to the object, go back without losing any information. And now the second reason is that MongoDB, kind of the biggest competitor in the space, did the same thing. they have a format called JSON, and they added kind of similar text. And so if you choose to move the data from Mongo to Oracle, you can do so without having to lose your timestamps. And the second reason that we wanted this binary format, and I think the more interesting one, is performance. So there's a lot going on here. It's kind of impossible in a short talk like this to do it justice. But for anybody that is interested, there's a paper we published in VLDB 2020, which VLDB is like a peer-reviewed conference on database systems. And so it goes into the gory details of what we did and why it helps us in the performance we get. Because basically, every database vendor is going to tell you that they're the fastest. But there's a couple things that are relevant to Java Access that I want to talk about here. But this Yahoo Cloud Service benchmark, this is like the gold standard of comparing performance from these NoSQL databases. And it's really simple, actually. It just measures the throughput and latency of operations like get and put. Sees how many on fixed hardware, how many reads per second you can do per example. And so we're very competitive on this benchmark, even with pure play NoSQL databases. And go ahead.
How do your benchmarks compare for Oracle when it comes to startup time and shutdown time? Because I'm thinking particularly for like testing of a Java application, and you're trying to run unit tests, and you need to be able to start it up, run your test, shut it down. Start up, run your test, shut it down over and over again. If your startup and shutdown times for your database take a long time, then your tests take forever to run.
I see. So like having the database in a Docker image.
Yeah. In fact, last month we had a talk on test containers. And can you, for example, put an Oracle database inside of a Docker container, basically, for testing purposes? Because then you can just blow it away, right? If your test fails, what do you do?
Yeah. So
what do you recommend for testing?
So this isn't something I know about. I know, so I don't know the performance question for testing the database coming up. So from my point of view, when we run these tests, the database is assumed to be up already, right? It's more about production type situation. But I do know a PM that gave a talk on doing local database and test containers.
Okay.
I can forward that to you afterwards.
Yeah, that's a big topic.
Yeah.
Is how do we test our applications with databases? That's a difficult thing.
Yeah, and I mean, we do think about that a lot, right? Because Oracle databases is really, right? It's not very big. And so like for testing and development, the ability to just spin one up and run it on your laptop. It's important, right? Right. So we are, providing Docker files and things like that. And we have Oracle database 20C that makes some inroads there and be kind of simpler to just kind of run on your laptop and test out without having to worry about licenses and things like that. Okay. Okay. So almost to Java. First, there's a couple aspects of this I need to explain them. So the first reason that this OSON, this binary format allows us to get good performance is that it compresses. So what this slide here is showing is D1, 2, 3, 4, 5. These are all, most of these are documents, JSON objects that we receive from customers. Some of them are from public data sets. But each of these bars is showing the size of the OSON, the JSON, MongoDB's format, and the JSON text, UTF-8 encoded JSON text. And so what we see here is that for the smaller size documents in this category, it's kind of a wash. They're more or less the same. But as the documents get more complex and bigger, the OSON tends to be much smaller. And what this means is two important things, right? There's less bits flying over the wire. There's less bits being stored on disk. And so when you get to this slightly larger category, just because less data is moving around, gives us a big performance boost. And the second reason is that it allows us to have random access within one of these objects, kind of similar to relational data. So let's say that I have an object here representing iron, it has the name and genre and the year. In SQL, I might want to just select the year about this movie. So here's the JSON column, here's the year attribute. What this format allows us to do, which other people's format can't do, is it allows us to jump directly to this year value without looking at the name of the genre. And this might not matter for like a small example like this. If you imagine the data being bigger to like a kilobyte or megabyte, the ability to just access that few bytes without scanning the rest of it can be a huge performance boost. So then what we do when you want to send this value to your Java application, we take this smaller image as it sits on the disk from the database, and we send it directly over the network. And so we're not spending CPU cycles on the server converting it to some other format. We're sending the smaller amount of bits across the network. And then when you get into your Java app from JDBC, we play exactly the same trick that we play on the server. So when I say I want to get the year of this object, it does the same thing. It's not having to convert this OSON format into like a Java hash now, and then access that year. So it's extremely low latency access to that first value in the data. And so that's kind of a little bit of our secret sauce here. And it's important to understand all of that context when we start looking at JDBC. Yes.
Are there any security issues involved when you do that? Because this sounds a little bit like the issue we have in Java with serializable. Being a security hole, if you read effective Java, he goes on and on about that. So, because what you're effectively doing is you're suddenly transmitting and you're running remote code on that other system, and you haven't vetted it yet, and you don't know what it's.
Yeah, so that's a good question. So with serialization, or even maybe you've heard of Jackson data bind, there's a huge source of CVEs for that, right? Security issues. But what's happening there is that it's because it's doing class loading on that data. People can do things like inject a different class name in the data table, and it can cause your Java application to execute that other code. That's what I'm talking about on this slide so far is really just APIs. So we'll get to it later in the talk, the kind of data binding, we're taking this data and attaching it to a Java class. But what I'm talking about here is kind of static APIs. We're not loading your code. We're just allowing you to access the data efficiently. So there's no class loading.
So there's nothing here that's actually going to execute. That's
right. It's
coming
like
across.
It's a library that we define in JDBC, and it's not loading your code at this level yet. So I'll get to that later on.
Okay.
But for now, there's no loading of your code. Yeah.
It also might be something you read a lot, so
Yeah.
But is there any downside for saying loading the entire object over the network when only one?
That's a great question. So the question was, is there any downside that we're passing the full value over as opposed to kind of streaming it from the server? So like, if you're familiar with relational databases, there's like laws, like law and clause, and those can stream, right? You can pull them gradually. For these document stores, it's very much a value-based use case. Like, so with MongoDB, the maximum document size you can have is 16 megabytes. For us, for these, it's 32 megabytes. So this is not a streaming use case. It's very much a high value use case because there's also downsides to streaming as well. But yes, there's trade-offs. But this is very much like value-based strings.
Yeah, I was thinking more specifically. There's example, all I want is the name.
Oh, okay, I misunderstood. So you can also do that, right? So like here, this is assuming that you select the whole document, but you can also say, I want to select the year and the name, and then just send that over. And in that case, the server will have to compute a new value for you and then just send that. Okay. So JDBC, the Java API for JSON and JDBC. So this has facilities to read and write models. Sure.
Okay, I'll put Jim said that seems
So having a JSON column seems kind of more like a data lake rather than a data warehouse architecture of data access. We recommend people generally try to move off or transition the data to not use the JSON column because of issues like what Jim said about treating more elements in JSON. Data engineer having difficulty with having easier time, like cutting down tables with send out information.
So for lake and warehouse, I think of anybody's use cases. And so these document stores are, the use case I'm talking about right now. It's mainly operational kind of OLTP type interactive use cases. We've got an app, the data is changing, we've got a lot of small requests. Oracle database is also used for both cases, right? For data warehouse and analytics type use cases. Loading the data, once it gets in, it's not changing.
If I could understand, what I felt like I heard you say was that basically Oracle is the best of both worlds in this case. Yeah, you can either ship the entire object, and you can take it apart on the code side, and you can change the piece you want, and you ship those parts.
Yes, that's right. That's right. So we're trying to compete on both fronts, right? On one side, we're competing with analytic cases like Snowflake or databases like that, Teradata, and all that. But on the other side, we're competing with OLTP operation stores like MongoDB. So we're trying, like we call it translate. We're trying to do both these cases.
So I'm trying to understand how you design when you have a mixed model like this, right? Because with traditional relational databases, you have what are called normal forms, first normal form, second normal form, third normal form, and all of that, right? But with JSON, I don't know what the normal form really is on something like that. So when you're designing your data store and you have a table and you say, well, this column is going to have some JSON in it, and that's column A, and column B is going to have some JSON in it. How do you decide how you're going to split that up? What goes in column A and column B, or maybe you need a column C?
It's not a simple question. Just using JSON doesn't relieve you of the fact you need to data modeling questions, right?
Right.
And I think, if you have as soon as you have an array in JSON, it fails first normal form, right?
Yeah.
You still have to do data modeling with this. And maybe we could continue this discussion like towards the end, because there are some things I'm gonna touch on.
Okay. I mean, I'm ahead of you here a little bit.
But I mean, there could be a whole talk on this, right? But just because you're using one of these document stores, you still have to, model the data.
You do still have to model the data.
It feels a little bit like the Sumo was doing with like logging, where like all the logs are basically just JSON logs. I can put that logging information in a column. And that way, the developer could choose to add extra information that I would have access to later through this mechanism, because it gives me that flexibility.
Yeah,
Right, but there would be certain key columns that I would care very much about, because I was using them to filter down my logs for
Right.
exactly what I want.
Right.
Which is the whole point of, I want that fast access of the document store versus the relational third normal form, right? And that's what is basically giving you that flexibility within the confines of this third normal form.
Right. So I see the use case. So I see the use case as being application logging. If you're logging things into this database as opposed to your primary.
Well,
store
that's
necessarily.
one possible use case, but like we have like banks using JSON for hiding transaction data. We have
Oh boy. Oh boy.
we have cryptocurrency companies storing like 3 billion JSON documents. So there's all kinds of use cases here.
Store your Bitcoins.
Yes. So yeah, just like, logging's great, but like some boxes in here. Yeah, so these APIs are in the normal JDBC jar, the main jar that you use to access the database. And there's a new package we added called Oracle.sql.json.
Okay, so I have a question again. Because I've been working with that jar forever. Why is 11?
Don't ask me this.
11 is the wrong time.
JDBC is very,
Yes, it is.
so, there's 8 and 11, why, and I kind of moonlight on the JDBC team, I'm not part of it. I think the long story is I don't know the answer to your question, but like it's targeted at 11, right? So the HR has to be 5 code, 11. Okay, right. So if you try to, yeah.
I was like, this is an opportunity, one opportunity to ask the question.
But it's a different convention.
I got it. Kind of like the naming convention of the database, when we want C+, like the way it works with these things.
Right, and it was 11G for good, and there's a new one for 23. Not sure if I'm allowed to say it, so but it's probably called 23. It's probably very. Okay, so what's in this package? There's this new package called Oracle SQL JSON, and there's basically 3 components to it. There's like a tree model, so you can represent one of these JSON objects as a tree data structure. There's an event model, and it allows you to represent it as a sequence of events. And then there's a factory that's kind of the getting started point. And so if you're older like me and you remember, XML and Jackson and all that stuff, this is like DOM, this is like stacks. And then, okay, so the factory, the starting point. So there's a set of methods in the factory for reading and writing this binary JSON format. There's a set of methods for reading and writing JSON text. And then there's like methods that you can use to do this tree model creation that create like in-memory back versions of this system. Okay, so the tree model. So basically, like DOM for XML, if I have this JSON object here with different values, right? This is a value, and there's values kind of nested inside. Each one of these values becomes like a node in the tree data structure. So I have a node for the object as a gold. I have a node for the string ironing. I have a node for the string state. There's a node for this whole array. And then there's a node for the 2 strings in the array. And then you're able to kind of traverse this tree by calling, methods on these objects. So that's kind of conceptually what the tree model is. And here's what it might look like in code, actually. So you new up one of these factories, you create a new empty object, put these key value pairs in it. And then here it's printing out, it's getting the name that you just put in there, and then it's printing out the 2 string method on that object. So if you ran this code that you see right here, it would print out what you see down here. So it prints out the name, and then it prints out serialization of that object as a JSON text. Here's the interface hierarchy in this package. So all the boxes here represent an interface in Java, and if there's an arrow between 2 boxes, it means that this interface extends this one. So everything extends Oracle JSON value. And so we have, at the leaves, we have a bunch of different interfaces for those extra types that I talked about on the binary JSON slide. So we have the floating point numbers, and the dates, and the strings, and all the primitive types. And then we have an interface for the object, an interface for the array, and they implement Java collections. So an object implements the map interface, and an array implements the list interface. And then there's kind of a common interface for the object and array. So it's pretty straightforward. So then that's the tree model. That's basically it. And then there's this event model, which again, if you remember XML, this is like stacks. And so every kind of piece of this JSON document now would be represented as a sequence of events. Okay? So you have like an event for the start of the object, an event for the key, an event for the value that follows that, event for the next key, and so on. So basically, you kind of stream through this value, producing events that you've got. And sometimes it's kind of convenient to work with it like this, or more efficient. And so then the generator is the reverse of that. So instead of saying next on these events, the generator is putting events, writing them to it, and you're building up a new object. So I'm not going to talk much more about this, but it's kind of okay. So if you're familiar with JSON, you're familiar with Java, maybe you've heard of JSR 374, which is you've used.
I remember I used it a lot.
Yeah. Okay. So this might look familiar to you because what we've done here in JDBC is basically be thought of as an extension to JSR 374. So this used to be in Java EE, and 1.0 it was under the Java X JSON namespace. But you know, Oracle moved Java EE to Jakarta, and so now it's all under the Jakarta JSON namespace for package. And so it's very similar to the API that I just described. They're the same concepts, right? The difference between ours and ours, really, we work with the engineers on the team on how to do this. But ours supports these extended types, some floating point numbers, where the Jakarta doesn't. And ours is immutable. So JSON-P is immutable. So if you have an object, what we found during use is that immutability is great for a lot of reasons. But when you have kind of hierarchical structures like object array, you just want to like change the status of one little line item deeply nested in a value. Having to create a modified copy of that can be kind of difficult for a lot of people. So ours is immutable, right? You can go there and just set it up. Wait a minute.
Yeah. So is that functioning like an ORM then? And you have like a caching over there? How's that happening?
So not multiple rows. This is a self-contained document and a column. Right.
Okay, so I modified my copy. No one else.
Right. So if you want to write it back, or I'll get to that. Okay. But here's the thing. It's kind of like a standard. I guess you're not supposed to say standard, but you didn't, want to just ignore it. So what we did is we implemented a sod package, right? So if you've got one of these interfaces in your app, at any point you can move to Jakarta or back and forth, and these are really just kind of like thought of as a view over the actual data. And so, like for example, if you have a timestamp and you want to go to Jakarta, there's no kind of corresponding view of that there. All they have is string. So if you switch to those interfaces, you would have to view it as a string. But anyway, so you can go back, you can use either set of interfaces. Because sometimes, like for example, you might have a library or something that's expecting the Jakarta interfaces, in which case you can consume those and access interfaces without having to actually convert the data. Okay, then there's also JSR 367, which kind of goes back to your question earlier. So JSON-B is kind of like what's it called in XML? JAX-B, I guess. The most popular way to do what this does, I think, is JAX and data bind. And so what JSON-B does, again, it's in Jakarta, and it's in the Java X, or it's in the Jakarta.json.bind package, is it allows you to take a JSON object and convert it automatically to like your code or your Java object in that, right? And so the other thing we did is we worked with that team to allow you to use JSON-B to convert your objects to OSON, right? And this is very cool because JSON's great for parsing text, serializing text can be expensive, right? So you get kind of the same kind of data bind mapping behavior, but you can do it without ever actually seeing the JSON text string. Right? So that OSON flows from the database, goes to your Java object, back to your OSON. No strings were created for purpose. So this, to your question about security, my understanding is that JSON-B has stuff built in to make it inherently more secure. So you can't do that code injection stuff. But I don't know the details. But
How do you, okay, so it does this mapping. Can you do just an entire object graph of just an arbitrary graph of Java objects and it'll just pull that all in and convert it into this OSON and just save it? I mean,
Yeah,
what
so-
restrictions do you have on your Java objects?
So that's kind of the generic question for JSON-B, and I don't know if there's like certain things that we'll see in Java and just leave it on. But generally, like it has some default behavior. I think it uses reflection and it'll map that to JSON events. And there's some default behavior, but then you can annotate your fields with these annotations that they provide if you want to do like custom mappings. Like so, say you don't want the behavior for some field.
Yeah, so you kind of help it out.
Yeah, you can help it out. Okay, so this is all, so far, all I've talked about is like OSON and how we represent it in Java, but I haven't talked about like how you send it to the database and back. And so the next few slides show how you can interact with the database. So like, let's say you want to get some data from the database. We basically use the standard, in the JDK methods, get object off of the result set and call it a statement. And so the idea is that you can specify a Java type that you want to consume your JSON value as. And so this table here gives the list of those types you can pass there. But maybe it's easiest to look at the example at the bottom here. So let's say that I'm selecting this data column, which is a type JSON. So I execute this query. I iterate to the first row. And then I can call the result set .get object. So one here is for the first column. And then I can say I want it as this Oracle JSON object interface. And so what happens then is that I have this movie here, and this is kind of what's happening underneath the covers here. So this is a pointer into that OSON format. So you can get it as a normal string if you want. It's not as efficient, or you can get it as these R interfaces or the Jakarta ones, the event model, or we even let you get your hands on the raw OSON bytes if you want to. Going the reverse way, what if you want to send data into the database? So start at the example on the bottom. I can do a normal insert with a bind variable here. This is a normal looking SQL insert. And then I do the set object method here. So I'm saying for the first bind variable, I want to send in my movie object, and I want to tell it that it's of type JSON in the database. And so there's different methods, again, standard methods in JDBC that we use to implement this. And the table here looks similar. There's slight differences, but you can send in all of these things to this set object class. And JDBC will take the value, encode it as the OSON, and then send it off to the server. And the OSON goes over the wire. It's important, though, to set this this third argument here. And the reason is that we don't do an extra round trip when we do this insert statement. And so at the time JDBC gets this statement here, like if you're sending it a piece of JSON text, it has no idea what it's inserting to be in a bar chart column, be in anything. And by telling it that it's JSON, it lets JDBC do the encoding of the OSON, and it keeps the CPU cycles off the server, which is usually a good thing, right? Because the database CPU cycles tend to be more expensive. Okay, so that's how you.
Do you have any issues with injection attacks here? I guess that's why you're using a prepared statement rather than trying to serialize that thing out into JSON. Insert that value.
Yeah, so this is a good question. And it's unfortunate that there is that possibility, right? Because if somebody takes that OSON image and they can tweak the bits however they want, and they can send it into a loop and stuff like that. And so the reality is that when that OSON comes to the server, we can't just say, okay, thanks, store it. But there's kind of a lightweight validation phase that happens on the server that it's much cheaper than it having to parse, but it kind of looks at the events and makes sure it's valid or sent before it lets it in. So yes, there is that issue, but we protect it. Okay. Okay, so performance tips here. This JSON factory does a lot of optimizations in memory tricks. And so if you use this Oracle JSON factory, you want to make sure that it's either global or it's not recreated with every request. And, avoid JSON text, parsing JSON text strings, serializing JSON text strings is expensive. So avoid having to represent your data as text. Use that third argument that we just talked about. And then this is just kind of generic stuff with databases, but you want to use connection flooring and state the caching. So creating physical connection to the database is expensive. And so you want to make sure that those are reused across requests. And it's
Just on that fourth bullet, is Oracle, I know they use can have some capacity. Pinging next to flags. Great other optimization that says be more forward data.
No, it's generic, but you're right, and it's called the network validation setting of UCP.
Could you repeat that?
Network validation.
For the listeners.
Okay, so the question was, for UCP, is there anything specific to JSON or is it just kind of generic UCP stuff? And the answer is it's the second thing. And the question also asked, mentioned network validation. So the answer is no, there's nothing specific to JSON. It's just kind of a common thing people don't do. And then, and there's a huge consequence to not doing. Yeah, network validation is important. There's different ways that can happen. You can, I think they've got 3 or 4 nodes, and you might send a select statement, which won't do that. And then there's this protocol level we call OSON, which is lightweight. And so like when we run it in our own cloud services, we set it to the network validation, which does this opening. And we also send the trust validation to 1 second. What that means is that if you're under extremely high throughput, that if that connection's been validated within 1 second, then it doesn't do an opening thing. So that setting, that combination is what we found was achieved.
I don't be really, it doesn't. It's a topic I know from the bottom past, but about, okay, the documentation says that locating is much faster than doing the round trip sequence statement, but I never really quantified that. Having inside information about the quantification, how much faster it is.
To quantify how much faster it is, I think I can provide intuition, right? I think that the idea behind opening is that it's just kind of gives to the server and response right away. If you're sending a select statement, right, that text has to be parsed, it has to be checked against the cursor cache, has to possibly be compiled. It has to go through the whole server stack. Where opening is just a little bit of data, and you can probably respond without going through the compiler. Yeah. But I don't know. Fair enough. Okay, so I have a demo. How are we doing?
You're really fun.
I'm gonna go through with the slides and then I'll come back to the demo, just so I have an idea what the numbers. No, what is happening here?
Remote is good, but people online can see.
Yeah. Do you disconnect the phone from the side?
The projector, the people online can see the screen, but we can. Connection can use the projector.
Let's see, screen sharing.
Are you sharing? Okay, I'm looking over here online.
Yeah, that's their mine.
I've seen it on my screen.
Okay, I think what happened is PowerPoint just crashed.
Oh,
Okay, so.
there we go.
Yeah.
Okay, so you'll need to share that screen. Yeah.
Okay, yeah.
With the online folks.
And we need to do a lot of editing here.
Sorry about that. I think I know.
Let it back in.
Yeah, as soon as he knocks.
As soon as you knock, we'll let you in.
How's the new job with something else?
That mean what?
New job,
Or,
was that you or? was it-
A minute,
or for somebody else.
I'm not doing audio.
I gotta let him into the room.
he is.
You already have them in there?
Yeah, he's,
I'm in, but I don't have permission.
yeah, just,
Yeah, you gotta upload his position, his permissions to share screen. Oh, that's okay.
you shouldn't have it now.
All right,
All right, sorry. about that.
online can see. We're good.
Okay, so I'm gonna continue with slides and then I'll go to the demo if we have time. But I wanna talk about Spring Data. Because all of the stuff I've been talking about so far is pretty low level. Right? And so a lot of people will use frameworks on top of the stuff to make interaction with the database easier. And so the most, one of the most popular frameworks we see is Spring Data. And so the next part of this talk is about, how JSON, using JSON can actually make Spring Data app more efficient. So. Okay, so Spring Data is a framework that kind of abstracts access to an underlying data store. And so there's different Spring Data adapters for different types of databases. And Oracle, for example, can actually be used with 4 different Spring Data adapters now. But it allows you to interact with your business objects as a repository of Java objects, kind of at a higher level. So the example on this slide, like let's say I have a Java object representing a movie. If I want to give that, an instance of this movie from my database, I would call my movies repository, and there's the method here that's automatically provided by Spring Data that gets one of these movies out of the database by its ID, and then I can access that movie object right away. So as opposed to like the stuff I've been showing you, there's no SQL statements. There's no like result sets, there's no rows, there's no JSON parsing. It's just like I'm calling this method find by ID, getting my movie and turning it out. So it's simple. And so the Spring Data adapter that I want to talk about today is called Spring Data JDBC. So Spring Data JDBC is an adapter that's implemented directly over JDBC drivers. It's supported by a bunch of databases like Oracle, MySQL, Postgres, a bunch of relational databases. But this adapter is inspired by a concept called domain-driven design that I think was introduced in this book by Eric Evans. But the kind of idea behind this is that you organize the entities in your database into what are called aggregates. And the kind of idea behind an aggregate is the things that are in an aggregate are kind of read and written as a single unit. And so like this example here is showing like a kind of classic purchase order schema, where you have order rows and they reference line items. The line items would have a foreign key to the primary key of orders. And then line items might have a foreign key that references parts too. So in this example, you very well might put orders and line items in the aggregate, right? Because if I drop my order, I don't want to leave my line items staying, but I would drop the line item sort of bit. I might want to establish an invariant across my line items, like an order total, like where if I insert a line item and change it in the way that it exceeds an order total, that's okay. If I locked one of my orders in its line items, I could probably do that in the system without, creating an excessive amount of lock contention, right? However, when I drop a line item or part, I don't want to drop those two. I wouldn't want to, leave and write the parts in the line items together. So the aggregate serves as like kind of a single unit of change. So here's a more specific examples from data JDBC. No, nothing about JSON. So let's say I have a movie class, and it has a list of images, and that image class is down here. If I wanted to access a repository of these movies in Spring Data JDBC, what I have to do is create a table called movies, and it would have the ID column for the ID field, and the name column for the name field. And then I'd also create a table called image, and image would have the file and the description, and it would have a foreign key that referenced the primary key of the movies. So this is kind of default Spring Data JDBC here, pure relation. And so then, assuming I did that, if I want to access and get one of these movies back, I have this really kind of sexy line of code here where I just give it the ID of the movie I want, I get that movie back. Really simple, not a lot of fuss. But there's a lot of database interaction, at least by default, going on in the background. So when you run this line of code, what Spring Data JDBC covered is going to do is it's going to execute the select query to get the movie row by the ID. And then it's going to execute this other select query to get all the images associated with that. And so right away, I added these two round trips to the database. And right here, right, I'm going to be predicating this query on the movie ID. So I'm probably going to want a functional index on the movie ID, so that getting the images, be done efficiently. So simple line of code, but there's some database interaction round trips going on here. So let's look at what happens by default with save. So let's say I have a movie, and I newed up my new movie, and then I want to save. So again, really, nice, simple, just save the object, goes in the database. But what's happening? So it's going to do first insert the movie row into the movies table, and then it's going to insert the image records, multiple image records into the image table. So again, right away, we've got at least a couple of round trips. And the other thing is, databases, Oracle and otherwise, they organize their data into blocks. Like I think the default block size in Oracle is 8K. And so maybe this movie just represents like 300 bytes or something like that. But now, because I'm doing it in two different tables, and different tables don't share the same blocks, I'm doing at least a couple of 8K formats to store my 300 bytes. So simple to use. By default, there can be some database interaction. So it turns out using JSON is a great fit for these aggregates. It can make them easier to use, and you can make them significantly faster. So faster because there's going to be less round trips, less index maintenance, and less random I/O. It also introduces schema flexibility, so you don't have to create these tables with certain columns and have them match your Java classes. The Java class now becomes the schema. So you get more flexibility, ease of use, and better performance. So that's what I wanted to say about that. So I have an example of doing Spring Data, JDBC to JSON, and also have some examples of the JDBC stuff, which I can do, or yeah.
So I gather what you're saying, what you're getting set up is you have less of an object relational impedance mismatch.
Yeah.
When you're storing this as JSON data than if you're trying to store it as tabular data.
That's right.
That you see as a selling point of trying to do it this.
So I'm gonna change my display, to no longer. Um, Okay, so, what I've got up to start this demo is I brought up, VS Code, it's a Microsoft makes VS Code, but the new, UI for interacting with local database, the thing that's replacing SQL Developer, is now a plugin in VS Code, so that's what I got up, it's just allowing me to execute SQL in this database. So to start out, I'm gonna create a table, called movie, just like the one I had in the slide, the column. Is. Okay, so we see down here, it says table created. Is this big enough for people to see? Okay, okay. So I've got my table with my JSON column, and I'm going to insert a couple of movies. So the first movie I'm going to insert here is the Shawshank Redemption, one of my favorite movies. It's a drama, and it's got its gross sales. That. And then another movie that I really like, The Matrix. So here now we've got the name of the movie, the genre, action, and gross sales, and I'm going to do a contact. So it doesn't have the same attributes as the other one. Right? I've got a contact, but that's kind of part of the point that you don't have to do. And then I'll just see that this works. So now down here, you can see that I got back the two JSON objects that I inserted. And as we discussed, it doesn't end there. You can query these from SQL with the columns. So now I get a very kind of familiar looking relational result with all the different attributes, the name, the genre, the gross, and there's contact. And one of them didn't have a contact, but that's okay. We just get a simple null there. Like this one. Okay, so now I'm going to go over to Eclipse. So to start out, I'm going to insert a couple more movies from my Java application. Okay, so there's no reason to use UCP here, but I always include it in my examples just in case somebody unknown copies my code and it's real. Because this is all on GitHub and so we get a connection to the database and we do an insert statement, but I think exactly like the one I saw in the slides. Do I need to make this bigger? Is it okay? You're fine. Okay. And so the next movie we're going to insert is Iron Man. And so here I'm just a regular old Java string with the JSON, and I'm sending it in. Because I use this third argument here, JDBC is going to encode it as OSON and send it to the server. And then down here, I'm doing it more programmatically. So I'm doing up one of these objects and creating a movie for Interstellar. It's a sci-fi. And I'm throwing in yet another attribute for the other ones on Hadoop called the release date. And I'm using the Java time library here, offset date time, to put in a release date for Interstellar. So I'm sticking a timestamp inside this JSON data.
So it executes this insert statement twice, once for Iron Man and once for Interstellar. Yeah, that worked. So it's down here at the bottom. Inserted two tables. So if I go back now to this code. Yeah. 4. All right. And now, going back to the place again. So let's see how we get these out. So here, I am getting the data column from the table, and I'm just iterating the row set, and I'm getting, I said don't use JSON text, but here I am using JSON text. I'm getting the object back as a string. So JDBC gets the OSON and it says, okay, you want a string, it serializes it to the text, and then it prints it to the string. So it's kind of like a hello world type example. There they are, the same 4 that we saw in this code. But let's do a more interesting example. So now I'm going to read data from the database again. But this time I'm going to make it more interesting. 2 things I'm going to do is I'm going to add a word cluster. So let's say that I only want to get back a release that grows to more than 500. So I select the data column, but I say where the gross sales is greater than 500. I set that from 500 to 500. And then I execute it. And now I'm going to do this efficient in place post stuff, right, to access it, right? So I give it back as one of these local JSON objects. And now I can get the name as a string. And so again, this is a pointer to the OSON we sent back from the server. I can access the name, the genre, and gross without, having to put it in strings or parsing the strings. Hope I don't do this. Back just the 2 movies that make more than 500 million. So we got Iron Man. Roll if I get the feeling from the good end. Not been great because, well, and this that'll make it. It'll just give you back no. I think it's just going to give you back no. There's another version of this method that has a second argument that allows you to have to default value. I hesitated a little bit because we followed the GSR 374, and there's sometimes where if you access something that doesn't exist, from the under exception, and it makes you use the second argument. Okay, so like, what if we want to update one of these values? Okay, so similar looking select query, but now I'm selecting the movie based on its name, and I'm gonna pull back just Iron Man, and then I get back this value. So here we've got a pointer to the OSON, return this object, and it's going to print it out to the screen. And so here's kind of a little bit of a catch, right? Because we haven't done anything, we just got this binary image sitting in memory that we can read from it, it's great, but we can't modify that on here. It's like, it's like a bunch of bytes, and there's no real way to modify that. So there's kind of subtle line here where it's making a copy of that object. And what this is doing is it's bringing it out of that OSON format into like a hash map based implementation that we can then mutate. And so here it's adding $1 million to the gross sales of Iron Man. And so then we're gonna, I think you had a question earlier, right? We've modified this object, but that's just sitting on the side. The database doesn't know anything about this change yet. So we have to send it back. And so we do an update statement where we say we want to set the JSON column to this value, this updated value, where the name is equal to this value. So we set it, here's our modified version of the object. Here's Iron Man, so we update the right one. and then it's, so it has to send back. Basically, replace the. But maybe we wanna like update attributes without having, like, what if this was a megabyte object? That would bring it down just to change the first sales and send the whole thing back, that's not too efficient, right? To have to move the document out of the database and some changes and. Yeah.
They need one conversation.
Like an optimistic logging type thing? It's a good question. So this is like normal SQL transactional, you do long running transaction, all that, but maybe you don't want to, you want to, you retrieve the object at some point, it sits in your application. You don't want to keep like the transaction for that. And then you want to put it back, but you want to know that you're not clobbering somebody else's change, I think is the question, right? And so people use for that optimistic run. And you can do that on your own, right? Add some version of problem. Spring Data will do that for you automatically in cases. We also have other APIs that also do optimistic problem for you. But in what I'm presenting to you right now, you would have to manage that yourself and add a version of it. So that's updated. And the last thing I want to show in this category is how you would update partially, right? Because if I just want to change one attribute into JSON object, I don't really want to log the whole thing out of the database, the whole thing back. So for that, we have different SQL functions you can use. JSON merge patch is one of them. So what we're doing here is we're updating the movie table, and we're setting the data column to the result of calling this JSON merge patch function on that column. And so the first argument of the JSON merge patch is the existing document as the server knows it. And the second argument is another smaller object that's just going to be patched in. And so it just has the attributes we want to change. And so this allows us to just send in the second binary variable just the data we want to change in the object without having to move the whole document around. So the patch here I'm creating is just setting the release date to something else, and it's changing the sales. So it sets those values and those pieces, and it's just gonna send those pieces to change the data.
I'm guessing that given the name of that function, it essentially mimics the specified for finding RFP.
Yeah. Exactly. With RFC, the RFC is it's like sit down and read the whole thing. But you're exactly right. It's still I can't remember the number of the RFC. Yeah. But so it's fairly so merge patch is great for simple things where you just mainly have object structures that you want to change. As soon as you start having things nested in an array, merge patch falls apart. But for those more complicated cases, we have another function called JSON transform. Example here, which basically lets you kind of perform more complex nested operations on the data. So JSON merge patch is simple, easy to use, but kind of has limitations. JSON transform can basically do any kind of nested modification. Okay, so we're nearly at 8, so I think I'll end it here. There's also an example of Spring Data that links in the slide. It's pretty straightforward in terms of the question. But yeah, I think I'll end it here if that's okay. And, yeah, thanks a lot for your time. Appreciate it.
So I guess.
Bruce.
Okay, well, thank you very much. I think we can end the recording here.